here of finding the limits as x approaches infinity. So look at the different examples here when we have to compare the degree of the denominator with the degree of the numerator. So little trick, the degree of the denominator here is the square root of a square, so it's really 1. So we divide everything by x in a numerator and divide inside the square root by x squared. And this is what we get there, okay? We find the horizontal asymptote this way. So look the difference between positive infinity and negative infinity. A little trick, pay attention to this. We have, as x approaches negative infinity, we'll have a negative square root. Make sure you contrast those two exercises. Sine of x, it oscillates between two numbers. Remember, the limit does not exist. A review from the past that we memorized. What's the limit as x approaches infinity of sine x over x? We use a little friend from the past, the squeeze theorem, to prove that that would be equal to 0. That's one of the things we memorized in the past. Finally, just a couple more examples to show how to work this out. Here, the degree of the denominator is 6 over 3, which is 2. So we divide everything by x squared. That explains 2x becomes 2 over x. And inside the root here, we divide by x over 6. I'm sorry, x to the 6th power. We end up with 0 over 1, which is 0. And the really one case here for the absolute value, I'm going to go over here and remind you of this. This is the example here. Read this out. The bottom line is this. For the absolute value of x, it's x when x is positive, negative x when x is negative. Therefore, we have these two cases here with 1 and negative 1. Thank you.